In April 2017, United States Special Operations Command posted a highly unusual solicitation. They asked American industry if it was feasible to reverse engineer and domestically produce a belt-fed machine gun originally designed by the Soviet Union. The request was born out of a stark logistical reality. For decades, the West had engineered increasingly sophisticated weapons, yet they had consistently failed to match one specific physical advantage of this foreign design. To see the gap, look at the NATO standard. This is the FN MAG, adopted as the M240. It's a reliable weapon, but unloaded, it weighs over 12.3 kilograms, more than 27 pounds. Now look at the Soviet equivalent. The PKM weighs roughly 7.5 kilograms. That is nearly 5 kilograms lighter than the M240, a number NATO spent 60 years unable to match. This weight reduction was achieved while chambered for the 7.62 by 54R. It's a cartridge introduced by the Russian Empire in 1891 for the Mosin Nagant bolt-action rifle, older than the modern machine gun itself. From an engineering standpoint, this ancient ammunition has a severe mechanical limitation. Notice the protruding rim at the base of each cartridge. This schematic shows how a modern rimless cartridge feeds. The bolt drives the round straight out of the belt link and forward into the chamber in one smooth, continuous motion. Because of that wide rim, the Soviet cartridge cannot be pushed forward. It would snag on the link. Instead, the mechanism must pull the round backward out of the belt, drop it down, and then shove it forward into the chamber. How did a design bureau take the oldest service cartridge on Earth, accept its worst feature, which requires more motion to feed, and finish 5 kilograms lighter than the people who did everything correctly? The answer starts in 1946. The Red Army wanted to consolidate its sprawling inventory of heavy infantry weapons, like this wheeled Maxim M1910, into a single, universal platform. For years, designs failed to meet the requirements. In 1955, the military cut the weight ceiling for a bipod-mounted gun down to a punishing 9 kilograms, killing off multiple prototypes. By 1958, one designer was ahead of everyone else. Grigory Nikitin built a weapon that followed all the requirements, passed trials, and was cleared for pre-production. Nikitin had won on paper. But in the summer of 1959, an officer casually mentioned to Mikhail Kalashnikov during the fishing trip that the Army found the Tula gun a little too complicated and wanted something simpler. Kalashnikov had no official assignment, no funding, and no formal engineering degree. He simply pulled money from other projects. Men in his shop worked from rough sketches and stayed until 5 in the morning to build an unauthorized prototype. He ignored complex push-through systems, instead using a simple claw extractor and small pivoting feed pawl, eliminating heavy steel cams. Applying the same logic to the body, he abandoned the thick milled steel receiver for stamped and riveted construction, significantly dropping the gun's weight. Next, he bypassed the military's demand for a brand new belt design. He reused the old Maxim and SG-43 belts sitting in warehouses, eliminating the need to engineer a new industrial ecosystem. When these weapons reached field trials, Nikitin's complex gas system was unreliable after being submerged. Kalashnikov's simpler design came out of the water and kept firing. The gun's extreme lightness was not a single breakthrough, but a dozen small engineering choices that prioritized simplicity over theoretical perfection. The competition ended at a research institute in Klimovsk. The committee was fully prepared to formalize Nikitin's victory. Kalashnikov was in Moscow that morning, with no pass to enter the restricted facility. A friendly officer dug a hole under the fence. Kalashnikov crawled through and entered the hall at 5 minutes to 10, his suit covered in mud. During the demonstration, Nikitin fumbled the disassembly of his own machine gun. When it was Kalashnikov's turn, he spoke for 10 minutes and produced a lighter prototype the committee didn't know existed. Standing in his dirty suit, he made a promise. If they adopted the gun, he would bring its weight down to exactly 7.5 kilograms. He won the contract, but because design work belonged to the state, Kalashnikov was forced to use the tripod and ammunition boxes developed by Nikitin. The system valued raw utility over individual ownership. By 1969, Kalashnikov delivered on his promise. The modernized PKM variant entered service weighing exactly 7.5 kilograms. The weapon spread across 4 continents, filling infantry, tank, and armored personnel carrier roles with a single spare parts chain and training pipeline. In 1999, Poland joined the NATO alliance. This presented a problem. The Polish army used the PKM, but NATO standardized on 7.62 by 51 mm ammunition. Instead of buying a Western machine gun, the Polish military rebuilt the Kalashnikov feed mechanism to accept NATO bullets, creating the UKM 2000. A NATO nation chose to rebuild its own supply chain just to retain the Kalashnikov architecture, rather than adopt a heavier Western design. Which brings us back to the SOCOM Request. In Afghanistan, U.S. troops realized their heavier weapons were being outmaneuvered by fighters carrying lightweight PKMs. Western engineers struggled to beat this gun because they optimized for mechanical precision. Kalashnikov optimized for the physical limits of the human soldier. Today, that lightness has found a new application. In Ukraine, photographs have appeared of commercial agricultural drones carrying a PKM. The drone can lift a full-power belt-fed machine gun for one reason only: 7.5 kilograms. Weight is the ultimate dictator of military design. A single mud-covered promise of 7.5 kilograms created a weapon that outlived its creator, outlived the empire that built it, and is still light enough to find new work on a drone.